Okay, next we are going to look over, this is a continuation of chapter 1.4, which for us is day 10, or depending on which class you're in, it's going to be day 10, or let me just double check, day 7. So depending on what class you're in, it's going to be day 10 or day 7 of unit 1. Just want to clarify. So in this part, we are going to talk about the angle addition postulate. And the angle addition postulate tells us that we can have an angle like the one I have in front of me and take the pieces and add them together, and it equals the whole piece together. Think about like a pie. If you take each piece of the pie and add it together, it equals the whole pie. So one thing I want you to remember is part plus part equals whole. Part 1, which I'm going to name this angle right here 1, plus part 2, which is going to be this other little angle, is going to equal the whole thing, the whole big angle, the whole enchilada. Now, when we talk about angles, there's some different types of notation that we use. When we're naming angles, we just use the angle arrow and either the number or the letters for it. So that's when I'm talking about, oh, this is angle 1. Oh, this is angle 2. When I am talking about the amount of an angle or the measure of the angle, I add an M in front. I'm going to move that. M angle 1. There we go. And I'm going to make a note that says this is read as the measure of angle 1. So that's something very important to note, the measure of angle 1. So if I was trying to talk about the angle addition postulate in terms of this angle, I could say the measure of angle 1 plus the measure of angle 2 equals the measure of the whole angle. Now, how am I going to name this whole entire angle? I have to think about the points. I can't say measure of angle 1 plus 2. That doesn't work. When you have the angles numbered like this, you can't like add them together to name the bigger angle. So instead, I have to use the points that make up the sides of the angle. So measure angle ADC. You could also say angle CDA if you want to go the opposite direction, that's fine. I could also name this angle pieces by the names of the smaller angles. So the measure of angle AD, and it goes up to B, plus the measure of angle BDC, or you could say CDB, doesn't matter to me. And again, is going to be measured equal to the measure of the angle ADC. So that's the angle addition postulate. Let's see it in some examples and maybe clear up some information. Here this says D is in the interior of ABC. I want to stress, I cannot stress enough, draw a picture. Please draw a picture. It will help you so much. So I have a big angle, ABC, and you don't have to be an artist. ABC, remember that middle letter tells you that's the vertex. And that D is in the interior. That means D is some point floating in the angle, and I can connect it with another ray and have cut this angle into 2 pieces. Now it tells me the measure of angle ABC, the whole thing, the whole angle, the whole enchilada. I'm going to mark this so that you can tell I'm talking about the whole arc of the angle is 120 degrees. And I didn't draw a big angle, so it's not visually accurate, but that's okay. And then it says the measure of angle DBC is 85. DBC. So just this piece here is 85 degrees. And I need to find the other angle. I'm going to put a question mark here for now. Or you can put an X. I think that actually might be better. Let's put an X. That's what I'm trying to find. Now I want you to keep in mind this angle addition postulate. Part plus part equals whole. Part plus part equals whole. So in my angle here, I have the part I don't know, which is the measure of angle ABD, plus the measure of angle DBC, and that all together is going to equal the measure of angle ABC. Now I can go and plug in the little pieces of information that I know. ABD is being represented by X. Measure of DBC is 85 degrees. And the measure of angle ABC is 120. Now, how can I go about finding X? Well, really all I have to do is subtract 85 from both sides. And that's going to tell me that X is equal to 35. So the measure of angle ABD is 35 degrees. Let's look at one more quick example and then we'll move on to the angle bisector. So point D is in the interior. I'm going to draw another picture because that helps me visualize where all of the pieces go. So D is in the interior, so D's out here. And I have A, B, C again. It says the whole thing, ABC, is 10x minus 7. And that ABD is 6x plus 5. And that DBC is 36 degrees. So now I do part plus part equals whole. So angle, the measure of angle ABD plus the measure of angle DBC should equal the measure of angle ABC. So I'm going to plug all the pieces in. I have 6x plus 5 is the measure of angle ABD, plus the measure of DBC is 36 degrees. And it tells us that the measure of angle ABC is 10x minus 7. So now I just have an algebraic equation that I can solve for x. So we combine our like terms and we get 6x plus 41 equals 10x minus 7. I'm going to add that 7 to both sides and subtract that 6x at the same time. If you prefer to do that separately, that's fine. 41 plus 7 is 48. 10x minus 6x gives us 4x. When I divide, that tells me x is equal to 12. So the measure of angle ABD, I'm going to plug 12 back into ABD, which was 6x plus 5. That means that angle is 77 degrees.